I want to talk to you briefly about what I'm calling the scientific method. And I want to introduce this by means of a simple problem. Let me state the problem for you. You've got 500 kilogram pile of cucumbers, and cucumbers are mostly water, 99% water. You leave them overnight, and some water evaporates, so they lose something. In the morning, you test them, and you find that now they are 98% water. What does that whole pile weigh now? So it was 500 kilograms. It's 99% water. Some water evaporates. It's now 98% water. What does it weigh? All you need is simple arithmetic for this. And many people will get it wrong. Some people might go through some sort of fuzzy reasoning saying, well, 1% of the pile has been lost, and 1% of 500 kilograms is 5 kilograms. So you take that off your 500 and you've got 495 left. Quite a few people will think that that is the correct answer. But let's approach it in a scientific method. There's your pile of cucumbers. And always when you try to solve a problem, if at all possible, draw a little picture, some diagram. All right, so there is a pile of cucumbers, and some evaporation takes place, and there's a slightly smaller pile in the morning. It weighs 500 kilograms there. Let's call it X in the morning. That is what we're trying to find, the weight of the pile in the morning. It was 99% water before. It's 98% water now. There is what we're looking for. We're looking for X. There it is again. There's our little summary of the problem. If it was 99% water, then 1% of it was hard stuff, which didn't evaporate. On the other side, then it's 98% water, so it's 2% hard stuff. And here comes the aha moment. It's the same as was there before. The hard stuff hasn't changed. So these are the same. Now, what does that mean? 1% of the 500 kilograms, that's the hard stuff before, is 2% of X, and that's what we're looking for. Those are the same. In other words, we can make an equation. 1% of 500 is 2% of X. And now we solve for X. Can you see it? X is 250. That's a little counterintuitive, isn't it? It weighed 500 kilograms before. It lost some water, 1%, and now it's 250. It lost half its weight. And people might not believe it, but there's no arguing this. This is the scientific method at work. There's absolutely no argumentation. It weighs 250, even though it seems counterintuitive. And in fact, you could convince yourself without using an equation, look, the hard stuff stays the same. Before, it was 1% of the pile. It hasn't changed. And yet now, it's twice as much. It's 2% of the pile, which means the pile must have shrunk by half, 50%. That is not quite convincing. It is true, but better to go through this process, which I'll outline now. Identify exactly what you're looking for. It was the weight of the pile in the morning. We call that X. Get all the information and put it on a diagram. Draw a little diagram if you possibly can, and put all of the information on that diagram. Introduce variables to describe the various things, and describe that whole problem in terms of those variables. Make an equation, a system of equations, or a differential equation, which we will learn about later. That's an equation involving derivatives, rates of change, or you might even need a whole system of differential equations, and then solve. Now, here's something that any mathematician will do when successfully completing a problem. Firstly, just check that it makes sense. And then secondly, see whether the problem can be generalized. So we draw a little picture again. Here's the pile. Now I've made it rectangular. And there is the amount that stays. So in the cucumber, for example, this is that hard stuff in the cucumber which does not evaporate. And let Q be the total quantity before. Then evaporation takes place and the pile is now diminished. So S stays again. This is the amount that stays. And X is the size of the pile after evaporation. So if I make a little legend here, S is the amount that stays constant, does not evaporate. Q then is the total known fixed quantity before evaporation. X is the unknown total quantity afterwards. The ratios we were given, the S over Q, this ratio here was given. In the cucumber example, it was 1%. So we know the fraction before, and we know the fraction afterwards. And we are looking for X. And the whole problem was solved by noting that S remains constant. So out of these, we extract S. So S stays constant, and S here is A times Q, and it's also equal to B times X. And then we solve for X. So there we triumphantly declare a little formula. It's A over B times the initial quantity. Let's put it in a box so we've got our result recorded. So the amount afterwards is this ratio, A over B times the initial known quantity before. In that cucumber example, this ratio, A here, was 1%. So it was 1% hard stuff before, 99% water. And B was 2%. 2% is the hard stuff, was 98% water. Then with our little formula, we get the quantity Q times A over B is X, the amount in the morning. So the fraction was 1 over 2, the A over B, and we got only 250 kilograms remaining. If we just try it out on a different one, say it was 99% water before, so the A is 1%. And supposing you test in the morning and it's 50% water. So these are the two ratios. 1% before, that's the hard stuff, 50% afterwards. Then using our little formula, the A over B here, there's the A, 1%, divided by B, so it's 100 over 50 instead of 50 over 100, and it's 1/50th. So in this case, you start with a pile of 500 kilograms, and you end up with only 10 kilograms. I'd like to add some afterthoughts to this little problem to do with the cucumbers. Just to recap, we had this pile of cucumbers, weighed 500 kilos. It's 99% water. Evaporation occurs. The pile's a bit diminished. It's now 98% water. What does it weigh now? So that is a little problem. And this is what we were looking for, this X, the weight afterwards. So we had a problem which had a solution. And in this case, the solution was surprising. It was counterintuitive. The solution was actually 250, and we applied scientific reasoning to get to that. And many people, when they presented with this, will say, well, look, it's 500 to start with. It's lost 1%. How can it be 250? They will apply their own common sense reasoning and say, well, it's only lost 5, so it's 495. And if this weren't just a problem to do with the evaporating cucumbers, if this were an important problem which needed a solution, and you relied on people just using their common sense, you'd be in trouble. And if the problem is, say, something to do with management, say management of a country, and you've got someone in charge of water or electricity or some problem that affects a lot of people, and they just apply their own common sense to get to what they think are solutions, but the solution is complex, then it's going to go wrong. And if you are training to be a scientist, you'll be presented with problems which require careful scientific reasoning to get to the correct answer. Common sense is not going to cut it here. So your training procedure is to learn to acquire mathematical and scientific tools with which you can reason to come to the correct answer. And you will no longer have to just rely on common sense, which can lead you astray.